I do have the red spots everywhere. Oh, yeah. It's all issues. Mhm.
Hello.
Good morning. How are you?
Just fine. How about you?
Good.
Good,
Okay,
good.
so well, we're going to do probably this might be our last actual lecture, lecture, but
Okay.
not I mean, if you still want to do the review in person, we can, so that way you can ask questions. But like I told you last time, it is recorded.
Okay.
So if you want to do that, that's fine. All right, so let's go and get started because we got a lot to do. All right, let's see. Oops, that is so not what I wanted to share. There we go. All right, so last time we looked at the types of reactions, and we said we were going to come back to this, just a quick look at it as in balancing. Let's see, where are you? Oh, nope, I passed it. It's the tutorial. Remember I said that we were going to come back to the tutorial.
Mm-hmm.
There it is. All right, so basically we're just going to classify and balance the ones that are there. Okay, here we go. It's going slow.
Mm-hmm.
Can you see it okay?
Uh-huh.
Okay, good. I'll make it bigger so you can see it. Okay, so all of these down here are the equations that we're going to worry about. For some reason, these are missing the little thingies. But okay, that's fine. It doesn't matter. It actually is better that they're missing it because it's a pain in the butt.
Right.
See, there we go. There's the arrow again. There, look, it all came back. You see that?
Mm-hmm.
That's weird if I put that one back. All right. So again, looking at this one, you can see this is a synthesis. Why? Because this is one product right here
Mm-hmm.
that was formed from two different ones. So that's the key to knowing which one is which. All right. So again, to look at how to balance, what you have to do is go against both of the ones that are on the other side with this one that I highlighted. And you can see that nitrogen is double here, but there's only one here. So the first thing to do is to put a 2 there. And yes, there is a 2 there. It's just in white. For some reason, it keeps doing it in white. I do not know why. It just does. Black, darn it. There. All right. And so now you can see that you have 6 hydrogens, so you need a 3 there. Okay, again, in white. See, this is what I was saying. This is a pain in the butt. There. Excuse me. And normally you don't have to put a 1, but I'm going to just in case your Connect does require it. I think it does. All right. So the next one, you're looking at it, you can see that this is a hydrocarbon that is combining with oxygen and producing carbon dioxide and water. So this is a combustion reaction. I'm just putting the initials, makes it easier. And this is the one where you need to look at the hydrogen as a trick, kind of like a quick little trick. And if you say, okay, this hydrogen, if I divide it by 2, it's an even number, then I don't have to double it.
Right.
So we start with the carbon dioxide, put a 3 there, and that gives us 3 carbons, which is correct. And then we need a 4 in this one. Come on, 4. Okay, now all we need to balance is the oxygen. And to do that, you need to multiply the 3 times the 2, right? Because there's 3 in front of a 2. So that's 6 oxygens in this guy under here. Let me see. Hold on, I'm going to annotate. Actually, I'm going to spotlight so you can see. Right here. 3 times 2 is 6, and then 4 times 1 is 4. So 6 plus 4 is 10 divided by 5 is, by 2 is 5. So there you go. That's all balanced. And like I said, I'm just going to put a 1 there because okay, again, it went to white. Why does it do that? Explain that to me. I haven't changed it.
Got a mind of his own.
Okay, so look at this next one. Look at what's going on. If you were to describe it, what's happening?
What's happening? A combustion?
No, not combustion because there's no oxygen. Number one, there is oxygen in the compound, but not by itself. It needs to be by itself. So look at the aluminum, how it booted out the copper. You see that? Copper is
Mm-hmm.
by itself. So this is the key for these. You're going to always have a lonely element. I'm
Mm-hmm.
calling it lonely. Oh, look at that. Brittany's here. All right. A lonely element. Okay. And that's what we're looking for. The lonely element in this case is aluminum
Mm-hmm.
on the left, on the reactant side, and on the product side is copper. So, as always, we always look at our most complicated one of the ones first and compare against. Okay, so if we compare against all the others, we can see that copper oxide, copper 2 oxide over here only has 1 oxygen. So we need a 3 right there. Remember, we always leave the elements that are alone or uncombined for the last. Okay, so now we got 3 oxygens. Now we have 3 coppers. So we need a 3 here, right? And aluminum is telling us there's 2, so we need a 2 there. And there it is, it's balanced. And this is a single displacement because copper was displaced by aluminum. All right. This one's a little more complicated, but if you look at it, it's the same because iodine is alone. You see that?
Mm-hmm.
And it is not alone here, but it booted out sodium. Booted out, not sodium. We booted out this guy. It just doubled it. That's the only thing. And that's why it's hard to see. You see that? But and then sodium still stayed with it because sodium's so darn reactive, it'll react with anything you put in front of it. So that's why it stays. But okay, so the most complicated one that we have, or the most, you know, atoms are in this one. So if we compare it against everybody else, you can see that there are 2 of I should say, double the sulfurs and the oxygens, right? So we need a 2 in front of this one. Now we have 4 sulfurs and 6 oxygens, like the one that I highlighted. Now here we have 4 sodiums. Here we only have 2, so we need a 2 in front of this one to make it 4. Or if you're just looking at the iodine, you could have done the iodine also, and this is the one also. So this was a single displacement with a tail, is what I call it, because it's got an extra component to it that it's hard to see, but it's there. If you look at it, the iodine actually replaced this guy in the iodine right here in this one, in the sodium. It replaced this guy right here, this part, let's see, let me make it green. See, got replaced by the iodine on this area. And it got displaced here. See? And I know it doesn't look like it, but it did. It did get displaced. It's a hard one. When you get types of reactions, they're going to be a little more straightforward than that, but it's always good to be able to recognize. Okay, what do you see going on in this one?
Mm.
What
This looked like something we did yesterday with the twos.
Yeah, exactly. A and B equals AB, right? So this is just,
Right.
that's
So
the
we just
same as
put
this.
a two in front of the last one.
Yeah, but we're first classifying the reactions. So looking at that, right? When you look at that, you can see that you need a 2 in front of this one, right?
Mm-hmm.
Because of the potassium. Now we have 2 oxygens, which is correct because we have one here and one here, one in the K2O and one in the H2O. So both of those are counted. You have 2 hydrogens and 2 oxygen, and 2 potassium. So that's good. It's balanced. Sometimes it doesn't take much to balance an equation. Most people want
Right.
to do more, but it's not necessary.
So on Connect, is it gonna ask us to put those ones there like you putting in front of those?
I think it might. That's why I'm doing it, though you're not really required to in a normal, balancing. But the reason I think they ask you to is so that it knows that you're done. You know what I'm saying?
Right.
Like it's the end of it. All right. If you look at this one, and if I take the SCN, which is a group, and I highlight them, and I highlight the SO4, I'm going to do that one in blue. No, let's do it in something more contrasty. Pink. There we go. Okay, it's quite obvious to see. See, most people would freak out on this one, but basically you shouldn't, because you notice that these are groups and they're the same. So basically you have 6 of them on the right and only 1 on the left, but you don't focus on only that. Focus on the entire molecule, which I am highlighting right now. And then I'm coming back and highlighting the green. Okay, because it's necessary. Okay, so the whole yellow molecule, right? The whole entire thing. Okay, if you compare to every component, you see that you have 3 potassiums, but that one you have 2 over here, so that's okay. You don't have to balance that one. But look at the irons. How many irons do you have on the other side?
3, 2.
2. That's right. So we need a 2 right here before we can
Mm.
balance anything. And see, if you had started with the potassium, you wouldn't know that you really need 12 right here rather than
Right.
6. You see, so that's why you need to compare every single element that's in the most complicated to the others. And then you figure it out. Okay, so the iron told you. Now, you have 12 potassiums on the right, on the left, and only 6 and 2, so 8 on the left. But look at the SO4. We haven't finished balancing, have we?
Nope.
Because on the left, we have 3 SO4s. On the right, we only have 1. So we need a 3 right here. And look at that. That balanced everybody. You see that?
Right.
And that is where you need to look at certain things. Okay, so based on the fact that I put 2 groups together, look at what's going on. The SO4 is with the iron over here,
Mm-hmm.
and the potassium with the SCN. Look over here, the potassium is with the SO4, and the iron is with the SCN. So that means this is a double replacement. See?
Right.
All right, this next one. All right, obviously this is the most complicated one of all because it is very complicated. So we're just going to highlight the whole thing and compare it against the others. But look at what's going on. There is only one reactant breaking up, you see that, into many. So this is a decomposition. Okay, so when we look at this, you can see that nitrogen, there are two, right? Based on this right here, this two. There are two on the left, but there's only one on the right. So we need to put a 2 there, right? Okay. Now look at the rest. It's already balanced. Isn't that interesting how quickly it balanced?
Right.
And it looked very complicated, but it's not. It really isn't. Because this gave you 6 hydrogens plus the 2 from the water, right? That gives you 8, which is what you have on the left. And then the CO3 is CO2 plus O. So we already got it. So all of these would be ones. If you were doing it on Connect, that's why I'm putting ones. But you really, I don't ever do that. All right, again, we're looking at the most complicated one being water, right? And this is another synthesis, because look, 2 things becoming 1. You see?
So you just need a 2.
Yep, exactly. You just need a 2 in front of the
H2O.
water. Yeah. And now you need a 2 in front of the hydrogen. Yep. And then a 1, but you really don't need that one. But all right, look at the next one. What's going on? Same thing. 2 things are becoming 1. You see that? That's another synthesis. See how you can tell?
Right.
Even though the numbers don't match, don't worry about that. That's what the balancing is for. And compounds arrange themselves according to certain rules. So they're not ever going to be exact, right? So what you have to look at is what you have there, not, just the elements themselves. Oh, look, there's magnesium and phosphorus, and now there's magnesium phosphate, or phosphide, actually, in this case. All right. So again, the most complicated one being this one. So we need to compare. And I'm going to show you, if you don't start comparing the right way, you are going to mess up. All right. So you would want to put a 3 in front of this, but don't, because look at phosphorus. There's a difference between those two. That means you need a 2 right there, right? A 2 here. There. Oops. It had quit being white. Now I need to make it black again. All right. And so now you have 4 phosphorus, and now all you need is that 3. And that again, white. I don't know why it does that. This is weird. And then 1 here, of course, right? See, look, that one wasn't even black. It's so annoying. All right, clear the drawings. All right, so last one. All right, again, let's just make our little groups. First, let's highlight the one that's most complicated, and that would be this guy, right? He's the one that has the most atoms of all. All right, now let's highlight our groups, because we do have a group that stayed alone, survived the process, and that's NO3. And by looking at that, you can see that there's 2 NO3 over here, right? But there's only 1 right there, so you need a 2 in front of that one. Oops, again with the stupid white. Why does it do that? I have got to solve this mystery because it's bugging me. And now you have 2 silvers, right? So you need a 2 right there.
Right there.
And there again, it goes white again. All right. I don't know why you're doing this, but you're annoying me. And everybody's balanced now, because even the chlorine got balanced. You see that? So that needs a 1. And look, the stupid thing went black. The ones went black. The ones I don't need went black. And okay, now look what's going on. The chlorine with the calcium got replaced by the nitrate, right? And the silver with the nitrate got replaced by the chlorine. So this is a double. See? All right. So that's how we do those. All right. So I'm not going to keep dwelling on that, because we need a lot to do. All right. So when I show you this next one, this is called molar mass. And the reason we need molar mass is because we need to convert things to moles. So molar mass is super easy. You're gonna just go, oh my gosh, that's so easy. It is, it really is. So we're going to do, you can either do this one or that one. It doesn't matter. I don't know why I have it here twice, but I do. So let's just do the bottom one. Okay. Molar mass. Here we go. What are you, molar mass? Molar mass. Come on. All right. So what we're going to do is we're going to fill out this one. First, the reason I do this sometimes is to get you to remember your previous stuff. So this one is sodium sulfide. Where's my L? Sulfide. There we go. Sodium sulfide, I because it's the single element, right? Okay, so since you know how to balance equations, you can also see that there are two sodiums, right?
Mm-hmm.
And if you look at the periodic table, what is the mass for sodium in the periodic table? Do you have one handy?
I don't know what I did with that thing.
Oh no, it's 22.98. Okay, so look, I'm multiplying it, right? Because there are two atoms of it, and
Mm-hmm.
every mole of sodium weighs this much. So we have 2 moles because we have two of them. All right, and then sulfur is just one, and sulfide or sulfur is 32.07 if you look at the periodic table. All right, so when you add them, you get the molar mass, which is simple, right? Let me get my calculator and get them done. Okay, that gives me 78.05. And if you look, they're all in grams per mole, hence the name molar mass. That's actually our units. I'm not going to put them every time. That's why I put them up there. So 78.05 grams in a mole of sodium sulfide. All right, this one is called ammonium. Yep, I did get the right one. And chloride. Chloride again, because it is the single element. And in this case, we have one nitrogen at 14.01, plus we have, and I put parentheses on this one, but I really didn't have to because nothing's being multiplied, as you can see, because there's
Mm-hmm.
only one, right? And then
Mm-hmm.
here we do need a parentheses because we have 4 times 1.01, oops, 1.01, that is hydrogen. And then we still have one more thing to add, which is the chlorine, which is 35.45. And if you do all the math, your answer is 53.50. And why 50? Because we have actually no 53.5 because we do have one that is multiplying by 4. Yep. So no, it is 3 sig figs. All right, the next one is copper. We know that part. And fluorine is a 1, so this must be copper 1. Oops, fluoride. Fluoride. Sorry, my typing skills. Okay, so now copper in the periodic table is 63.55. And there's only one, right? So we don't need to multiply anything. And then fluoride is 19. So this is equal to 82.55. Okay. Copper 2 fluoride, on the other hand, has one more. So the molar mass is going to be bigger by 1 atom of fluorine because there's 2 of them this time.
Mm-hmm.
And the answer to that is 101.55. All right, that's those. Now, those are easy. We're going to just give the name to these, but we're going to, since you already know how to do these, there's nothing interesting or different, more like not interesting, but different about these because you can tell how many atoms. But
Mm-hmm.
this one, nickel 2 chloride, so it's Cl2. Okay. All right. And that one also. So we're not going to do that one either. I mean, why? Copper through 2 nitrate, though, that's going to be interesting because copper is multiplying the nitrate times 2. So now we have a little different situation. And you should know this one also because of the balancing that we've been doing. So
Mm-hmm.
copper is 63.55, right?
Mm-hmm.
One atom, and we only have one. Plus, we how many nitrogens do we have?
3.
Two,
No, it's 2. Mm-hmm.
because this is the two, right?
Right.
And that's multiplying the one that's here. So that's two. So 2 times 14.01. I know half of these by heart, not all of them. But and how many oxygens do we have?
So the oxygen is what the 3 is.
Well, yes, 3, but then times 2 again. So 6,
Right.
right?
Mm-hmm.
And that is 16. And that gives us,
187.56.
well, look at you. You did that fast. 187.57. That's correct. And then I'm not even going to try this one because this is just for you to remember the you know, the naming and also do
Okay.
other compounds. But these are all,
But for the most part, that's all we have to do on this sheet.
yeah, that's it. See, this is H2SO3 because it's sulfurous acid, not sulfuric acid. So it's the ite. All right, that one's also very straightforward, right?
Mm-hmm.
Hydrosulfuric acid, H2S, that's easy too. It needs to be an aqueous form. Why? Because we are acid, not gas. So that's the only one thing is that whenever you have a binary acid, which has a hydro prefix in front of it, that's how you know,
Mm-hmm.
then you have that. Okay, I know what it is. Haha. I need the other sheet because the other sheet has extra stuff. But you've seen all of these so far, right?
Mm-hmm. Mm-hmm.
All right, so we're good. I'm gonna, oh, darn it. Where'd you go? All right, this one. I need this one because this one not I knew it. There was a reason why I have that other one. It's a little different. It has extra because I added one extra, which I use for something else afterwards. All right,
Okay.
so this one, see how it's got two more?
Mm-hmm.
Okay, so the last, we already did that one. Okay, so ammonium phosphate is going to be NH4, right? NH4. And phosphorus is 3. Phosphate is 3, so PO4. All right, see, this one is multiplying everybody also. So we're going to do this one. I'm just making it pretty. I can't stand when they're not subscripts. They drive me crazy. Okay, so we have how many nitrogens? Three, right?
Mm-hmm.
And then that is times 14.01. That is our, and then plus how many oxygens? I mean hydrogens. Did I say oxygens? I meant hydrogen, sorry. There are 4 times 3, which is 12. See, that's where this is important that you understand that that's multiplying everything that's inside that parentheses. And
Mm-hmm.
phosphorus is 30.97, if I'm not mistaken. All right, where are you, phosphorus? Yeah, that's right. All right, so 34, 30 point, Lord, I cannot speak today. 30.97, I think that is correct. I want to say that's right. Okay, where are you? There's my periodic table. I just want to make sure. Like I said, I think I know these all by heart, but then I screw up sometimes, so I'm going to make sure. 30.97 plus, we have 4 oxygens from 16. Okay, so you're the fast calculator, so you do that math.
Oh, the number's tiny. Is it
Uh-huh.
gonna be 149.09?
That sounds about right. Is it '09? I'm not sure, but I think
Uh-huh.
that's right. I think that's right. Okay, this one is a really hard one. Nickel 3 sulfate hexahydrate. So you
Ew.
got nickel, and remember the sulfate has a 2 negative, so it's 2. Then you have SO4, which is what sulfate is, and 3 from the nickel, and then you have a dot with 6 waters. Oops, waters, H2O, because that's what hexahydrate means. So we're going to get this one, make it pretty, because I don't like it like this. Okay, so in order to do this one, you have to multiply a lot. You notice I'm not taking that front one because that's a coefficient, right? So we're not making it smaller. Let me get this bigger so that we can have the whole formula in one row. There we go. Oh, maybe that needs to back up. All right, now let's do the math. How many nickels?
I can't see those tiny numbers on this page.
Oh, you cannot see them? I'll
I
make it
don't know. Yeah, make it bigger for me.
there. How's that?
Okay.
Okay, so 2 times what is nickel? Nickel, nickel, nickel. See, I don't know these. These are not my friends. They're not the ones that I use all the time. 60, no, sorry, 58.69. So that
Okay.
is the number. Okay. And then we have how many sulfurs?
4 times 3?
No, 3, just 3.
Just 3?
Yeah, because the sulfur has a 1 in front of it, remember? Which is
Oh,
never
okay.
written in chemistry. And
Okay.
sulfur is 32.07, I think. I want to say that's correct. Yep, that is correct. Plus, how many oxygens do we have?
4.
Times 3.
Mm-hmm.
Don't forget that 3. So that's 12. And the 16. And then we got water. And the reason I'm going to put water as a whole, okay, is because that's usually how they calculate it. And water is 1.01 times 2, so that's 2.02 plus 16 is 18.02. Okay. And that mass is pretty large, so I'll let you do the math.
I'm
You
adding it up now.
see, I know you're fast because I'm still typing and
Uh-huh.
you're already adding.
We got 392.09.
Oh no, it's bigger than that.
That's what it gave me. I must have did something wrong then.
Oh, no, that's right.
Because when you put it in the calculator, you have to add the parentheses.
Yes, you have to multiply. Okay, so the way that it's done, it's the parentheses each time, right?
Uh
So
huh.
you open parentheses always. Let me clear all this. Okay, open parentheses and then put 3 times 14.01, close it, then add. Oh, what in the world? Okay, why does it say
Okay.
negative? Wait a minute.
12.
That says negative instead of a. Okay, there we go. It's like, what? I must have hit the wrong thing. I did. Parentheses. Oh, I said 3. What am I doing? I'm doing the top one. You didn't say anything. 2 times 58.69, right?
Mm-hmm.
And then plus.
Oh, 63109.
3 times 32.07, then plus another parentheses, 12 times 16. Just that was a lot. So that's why I was
Yeah.
saying that. I know that's not right. Probably going to be in the 500s. 6 times 18.02. Yep, 513.71.
Oh, my goodness.
All right, so that's our molar mass. It's 513.71. I'm going to make it, we can see it all. There we go. All right.
Uh-huh.
Now, the next thing we're going to do is called percent composition. So to know what the percentage of every single thing that we have in there by mass, what you do is you take the nickel, whatever's this right here.
Mm-hmm.
See, look, this is why I did it this way. So it makes life easy for me. Yay. See, Control V divided by the ending, right? Which is this one, the molar mass. That's the total times 100. See, percent oxygen. No, percent, what's next? Uh, sulfur. Sulfur. Okay, so percent sulfur is going to be equal to, see, I'm just copying and pasting this guy, right?
Mm-hmm.
And divided by, I might as well just copy paste these two because that's the same number. See? Boom. And then the next one is percent oxygen, right?
Mm-hmm.
And that is equal to 12 times 16 divided by all this stuff. And then the last one is the water, percent water. Which is equal to the last part, which is 6 times 18.02. No, don't do that. Divided by the bottom. And that's it. Each time you're going to do it right. There you go. Now, I know you by now you have calculated all of these. So what did you get? And you have to do,
I actually did that time. I was taking a picture of that, what you just did.
oh, okay. And okay, so you didn't. Gotcha. All right, so that's fine. That's fine. Percent composition is to be calculated right now, so it's no big deal. I'm just gonna bring it up a little bit. Why does it have such large spaces? Anyway, it's just, it's okay. So this is equal to 2 times 58.69 divided by 513.71 times 100. And you can put the times 100 all at once. And it gives me 22.85. And we want the amount of sick. Where's my 2? All right, you little girl, what you doing? Pretty baby. Oh, sorry, that's my kitty. This one is 3 times. You probably have calculated them by now. I'm slow.
I did. I'm just watching you do it now.
I got 18.73%, obviously, because it is a percentage. And if you want to put, I mean, it does say it in the front, but, just so that you know which percentage you're looking at. And then this oxygen is 12 times 16. I'm telling you, you're probably done by now. I get 37.38, right?
Uh-huh.
All right. And the last one is the water. And that one is 6. Oh, this is not meant to be there. I think it's when I put the divided by, it went to the wrong spot. All right, so this is 6 times 18.02 divided by 513.71 times 100. And I got 21.05. Okay. If you add them, and I'm going to let you do that part, together, you should get very close, and I mean very, very close to the answer that I got, which is
Okay.
100. I mean, but very close to 100. So let's see if you get that. Okay.
So what we doing? What I gotta do?
You're adding 22.85 plus 18.73 plus 37.38
See.
plus 21.05. And I got very good results, 100.01, which is good because if you had screwed up, you
Oh, I
would
got
get
that to
100.
1
Yeah,
0
you
1.
wouldn't get 100 if you screwed up. So that's
Mm-hmm.
perfect. All right, so there you go. That's how you do percent composition. Oops, that's a 7. And that's it. Very simple, right?
Okay.
All right, so now I'm not going to say that. Now we're going to go to moles. Moles are, okay, so if you have a dozen, how many do you have?
12.
Exactly. If you have a dozen sheets of paper and you have a dozen chairs, which one weighs more?
The chairs.
Well, of course, see, you know this. See, so dozen is a counting number, just like moles is a counting number. This number right here, see it? Right there.
Mm-hmm.
6.02 times 10 to the 23rd, also known as Avogadro's number. Okay. All right. So we are going to do some conversions. But first, you're going to look at something that is very good to look at, which is called the mole conversion diagram right here.
Mm-hmm.
And you might want to take a picture of it because it kind of tells you which way to go someday. Someday. Come on, baby. There we go. All right.
Just take a picture of this.
Take a picture of that.
Okay. Gotcha.
And we're only doing the yellow brick road, not the blue and green brick road. So just the yellow and gold. You see how there's yellow and gold going
Uh-huh.
horizontally? Yeah.
The particles.
Yeah. We do the other one in the other class, which is Chem 2. And we don't have Chem 2 right now. So that's why we're not doing that one. But this is the one that we're doing. All right. So once we do that, we are going to, sorry, I'm doing something and I'm trying to talk and do two things at once, and my brain doesn't work that way right now. It doesn't want to. All right, so we're going to do conversions. And the conversions are super easy. You notice that we just learned how to do this part, right? The molar mass.
Mm-hmm.
We just learned how to do that. And we know what Avogadro's number because it's written right there, right?
Mm-hmm.
So that's all we need. We are armed and ready. All right, so the next thing we're going to do is do mole conversions. I'm going to, here we go. All right. And this small conversion sheet has the answers, which is a practice. So why not, right? And the reason it has the answers is in case you want to keep practicing. I'm going to do a couple, but you can keep practicing. You'll know if you did it right or not.
Okay.
Okay. So in my case, what I'm going to do is I'm going to insert a table in here because this is that kind of thing. I don't know if you remember that dimensional analysis we did. That's all this is. So we're going to do 2.00, 2.0, come on, 00 grams of platinum. All right. So the next thing, if you look at your diagram, it says to look for the molar mass of platinum. That's directly in the periodic table. So I'm going to do that right now, if I can find my periodic table. I think I stuck it in something. Yep, sure enough. All right, there it is. Okay, so platinum is 195.08 per mole. So 195.08 grams of platinum goes on the bottom because we want to get rid of it, right? 1 mole. And that's how you abbreviate mole of platinum. All right. But that's not where we want to go. We want to go to number of atoms. So according to your little diagram, it says to use Avogadro's number. And 1 mole should go on the bottom because we want to get rid of it. And now Avogadro's number is right here. And that would be atoms of platinum. Okay, so this should be too elevated, but you know, I'm gonna do home and do that. There. Okay. So when we multiply, divide, and notice I am not going to even use my calculator for the exponents because this is simple math. And you'll see that what I taught you works here. So 2.00 times 6.02, right? Notice I'm not putting anything else. Divided by 195.08. That gives me 0.0, no, 617. And we're trying to get the number, oops, 617. We're trying to get the number just like it is up there. You know, see, 3 sig figs, 3 sig figs, right? All right, and that is grams. Sorry, no, atoms. But okay, so we're not yet finished, right? We need to do times 10 to the 23rd. This. Because we didn't multiply it before, but we can now, all right? And that's going to be atoms of platinum. But we're not finished yet because that's incorrect. Remember how we did the increase, decrease thing? Okay, so we're increasing it by 1, 2. So we need to decrease this one by 2, which gives us 6.17 times 10 to the 21. You see that? And isn't that what the answer is? The E means times 10 to the, I was lazy that day. I want to do all this that I'm doing right now. All right, and there you go. And that's, of course, atoms of platinum. See? And there you go.
Okay.
Pretty simple, right? All right. Let's do one that's going the other way. This one right here. We're going to insert the same table because we need just 3. Each time it's going to be 3. Okay, now it says we want this many atoms of mercury. So I'm just going to copy this so I don't have to raise it to the power of anything. All right, atoms of mercury. Okay. So how, again, 1 mole of mercury, remember that? That's from your Avogadro's number. is down here, right? So we're just going to copy this, put it down below, which is where it should be. But in this case, it's mercury. But remember, a dozen's a dozen, right? Doesn't matter if it's mercury atoms or platinum atoms. A dozen's a dozen. So that's why this number is the same. The one that's not the same, and it'll never be the same, is the mass. Just like you told me. No, of course it's the paper that weighs less or the desk that weigh more, right? Exactly. Well, same here. So we need to figure out how much mercury weighs on the periodic table is 200.59. So above that is going to be 200.59 grams of mercury is equal to a mole of mercury. All right. So again, remember how we want things to cancel. So we didn't do it on this one, but let's do it. Look, grams of platinum cancel with grams of platinum, mole of platinum cancel with mole of platinum, and we have the question. Same here, atoms of mercury cancels with atoms of mercury, moles of mercury cancels with moles of mercury. We don't have the answer yet, but we do have the answer to the question in the correct form, which is grams. You see that? Which is all we have to do now is multiply, divide. Okay, to do this, again, just do the multiplication like you would on a normal paper, just multiply it. And it'll be 1.19 times 200.59 divided by, oh, well, let's do equals first. Divided by, okay, clear, delete that.
Mine came to 3.96.
Divided by 6.02. All right. And you get 3.965, right? Which is, okay. Okay. So 3.965, no, it's 0.3965 actually, right?
Mm-hmm.
So 965 is 97. Yeah. Okay. So times 10 to the what? Well, we have 23rd on top. You notice how I'm just copying these numbers. Oops.
Mm-hmm.
Oh, undo that. I meant to copy, not paste. Control C. All right. I'm just pasting it right here. See?
Mm-hmm.
And then we have another times, right?
Mm-hmm.
And the times on the bottom is the reciprocal. So basically, this again, but negative. And remember, when you're multiplying atoms, oh, it's not going up there. That is annoying. Negative 23. There we go. All right. See, it's like saying zero, right? So times 10 to the 0 is like multiplying times 1. So the answer, oh, sorry, I said 0.397. It's 3.97, 39.7, sorry. I'm crazy. I have it set on something and I saw it. I saw negative. So see, there it is.
Okay.
So it is, the answer is 39.7 grams of mercury, just like we did. All right. So all of these are the same. The ones on the bottom, if you look at them, it's just going not all the way through. Just look at what they're asking. They're asking for number of moles, right?
Mm-hmm.
That's what we want to find. I'm going to highlight it so we keep that in mind. All right, so what do we need? All we need is the molar mass. And actually they gave us, didn't they give us
Mm-hmm.
the question? I mean, they gave us the formula in the question. Okay,
Mm-hmm.
so you know the molar mass. Okay, let's first do 17.2 grams, right? And we're
Mm-hmm.
just gonna call it benzene because it's probably easier to write the name than it is to put the formula, although we could copy formula. All right, so 1 mole of benzene, that goes on the top, equals, well, let's find out. So it is 12 point, so it's 6 times 12.01, that's carbon, plus 6 again, right, times 1.01 and that's the hydrogen, and it is 78.12. So that's the answer over here, grams of benzene. All right. That's all we need. See, we don't even need this extra one, do we? Because they just want to know the number of moles, and we just did that. So all we have to do is divide, right? 17.2 into 78 above, divided by 78.12. And that gives me 0.220 moles. And why do we want that zero? Because we want the same number of, oops, sorry, I'm looking at the wrong thing, moles of benzene. See, that's our answer. It worked. All right, what if we're going the other way? What if we want to do the mass from a number, I'm sorry, the mass from a number of moles that we have. Okay, so let's do that one. Same thing, except backwards. Same concept. Just and this time we know we only need two, so we're just gonna put in two. All right, so the question is this. We have, and I'm just gonna copy, you know what, I'm just gonna copy the name because it'd be easier for me rather than copying the, okay, so that's our question, right? That's what we don't know. And look what they want. They want the mass. So this is what we have to figure out. That's our question. So we need to go to mass. That means we need molar mass. So 1 mole, I know this is a pain in the behind because it's tin 2 sulfate. Look at the thing. It is just SN. So tin is 118.71. And then we've got sulfur, which is 32.07, plus oxygen times 4, right?
Mm-hmm.
That's 16 times 4 equals, I get 214.78 on the top. Why on the top? Because we want grams, right? We don't want moles. We want moles to go away. Sorry, I just want this gone. There we go. See? All right, so there we go. What do we do? Multiply, very obviously. And my answer is 40.2. Is that what it says? Yep, that's exactly what it says. See? So it's pretty simple to do that. All right, let's do this next one. Oh, and look, there's a percent composition for you. And it is already given to you, but you need to get it. So there's a different percent composition. All right.
Okay.
All right, so these are mole to grams, grams to moles. This top one is the hard one, right? Because it's going all the way across. So you need 3. Here you only needed 2. See, I'm going to erase this one because we don't really need it. Delete columns. Yes, there you go. See? And that's basically all. You want to do one of them on your own and see if you can get it?
No, I don't want to.
You don't want to. Nope. But you can see how to do it though, right?
Yeah.
And you have the answers. So if you don't get it right, you can always try again and figure out why. Yeah.
Exactly.
All righty. So basically that's all we had for today.
And then what day is the final test?
The
The final
final opens on the 4th.
on the 4th.
Yes, ma'am. And all of your tests that you are, I don't know if you've already taken them, I have extended, one of the things that I told you guys is that I always give you three chances. Well,
Mm-hmm.
I had forgotten to do that. So now you have three chances
Okay.
for all of
Okay.
them. So if you didn't do well on one of them, you can go back and take it now.
Okay. Okay. Because I think the stuff that we're going over, this is the only few things that I have to do left.
Okay.
But I think everything is done except for two of the reading assignments in
But the
Connect.
reading assignments, we don't have any more reading assignments beyond
Okay.
the third, chapter 3.
Right.
So that's good. You don't have to do those.
Okay.
Let's see.
But everything else is done, so I can focus on this and I can be ready for the final.
Yes, and like I said, if you want to be here for the review, that'll be happening Monday and Wednesday next week, same
Well,
place.
I have to be on campus for anatomy with Dr. Ken anyway,
And
so that
that's exactly why I have recordings. See,
yeah,
look.
that's yeah. I'll be there because for your class, it'll start at 12:30, right?
Yeah.
Okay, so I'll just be getting out of Dr. Ken's class, and I could just walk on down the hallway.
Oh, okay. Well, I was saying on same time, same place, like right here.
Oh, okay.
Yeah, you can just
I can meet you here. I can meet you here.
yeah. And but if you can't make it for some reason to part of it, look, see this? I'm showing you.
Uh huh.
That it even tells you part one, problems 1 through 19, solutions to problems 1 through 4 for A, C, E, G, and I.
Okay.
For 5 is A, C, E, and F. And then it tells you which problems. 11, you have A through D, and 12, 14, 15, 16, 18 and 19. And then part two, problem one only. And then see, looking forward, complete parts 2, 3, part 1, final exam, print or have handy, blah, 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 blah. So, I always did that. So basically, I'm going to go by this exact thing and we're going to do exactly the same ones. And here they are. So um, they are all on, like if you want to listen to it again after I do mine, then you can just come back and look at whatever you didn't understand back on
Okay.
these lectures, because they really are going over everything that is saying right there. See, and you got chemical equations,
Mm-hmm.
mole conversions, percent composition. See, so all of it is right there.
I should be fine because I caught on to everything pretty good Monday.
Okay.
I caught on to everything pretty good, and I need to take a nap before I do anything else today.
Okay, well, go take your nap, lady. Enjoy it.
I got a couple more exams to take for other classes, so I need a nap.
Okay, well, that's good. I mean, that's all you need.